Hello, good evening to everyone. My name is Mustafa. We gonna talking today about our presentation and our research paper. This one is our research paper. I will show you. This one is our research paper, and this one is our presentation. The presentation was malware detection, kernel behavior analyze. Firstly, what is the malware detection? We understand the basics, eleving threats, diamond dynamic solution. Modern cybersecurity must adapt to new and unknown malware. This requires a shift towards more a dynamic and intelligent detection method to stay ahead of elevating threats. We have a caption. This is the caption detection method elevation. We have two sides. Unknown threat is a 9%, and we have unknown or a new threats. We have 20%. And secondly, why the kernel behavior analyze is circle of security. A simple file operate system architecture. We have a web browser and user files. We have the system call and hardware required. The kernel is we have three sides and CPU and memory and advice. And the kernel as a secret checkpoint. The kernel is manages of the fundamental system requires it handles a hierarchical system calls required from the program, and the manual most intelligent with the kernel to prove the malicious actions. Observing kernel active proves deep intelligent into the true program behavior. Automation of the traditional malware detection. We have three diagram. The elevation rate of the signature past two direction. We gonna say of it's from the 0 to the 75%. And detection method calibration, we have the signature past and higher stick past. We have the pros and cons. The high speed and low resource using very low rate of the false positive. And the other side, can you detect new unknown malware and protective defense against zero by threats. And the cons, reactive and cannot detect unknown threats easily bypassed by polymerism and auction. And this one is higher probability of the files positive, can be the result. And okay, the key limitation is aviation technique. We have the recate, natural and obfuscation and prolongation, and limit is visibility. We have the signature detecting and record noun and bulletin making and activation against new unison and thirst. The five, we're gonna talking about the over review of the kernel behavior analyze method. We have the four caption. The observable kernel events. The system calls process creation memory access. And two, the mentor key behaviors, and 3. A synthesis integration is the file system change integration and acting. The analyze chronology and cannot detect events into the secret. The result we're gonna be the finally by mechanic active print by analyze the print bulletin of the this low level and behaviors and nuclear and probably and fingerprint of the managing Magellan's active is a credit employing process that through introduction.
Hello, my name is Hussein Wendy. Today I'm gonna represent my project with my team. So I'm gonna continue with my slides. The architectural components of kernel behavior analyzer. It contains 5 steps. Kernel events collector that gathers the raw data and system instructions. Behavior logger store events for subsequent analyze. We go to step 3. It's like a feature extractor processes raw events into meaningful behavior features. And 4. ML role engine analyze features for an analyze. 5. Alert system notifies administration or take automated actions upon detection. We have step 3 and step 4. It's connected to the step 5. I'm gonna go to the next slide. Techniques for kernel events collections. An overview for kernel events. Interruption methods and their performance characterized. Kernel events interpolation method. User space application A. Request kernel resources. Kernel resources connected to the kernel space. System calls. It contains system calls traces, eBPF, safe affection monitoring, Windows ETW, low overhead tracking, kernel hooks, executes custom codes, and keyports tracks dynamic instrumentations. Performance overhead comprehension, and as you can see in the schedule, we have the kernel hooks and SYS tracks and keyports. Like everyone has his own percentage from high to low. K behavioral features, suspicious kernel events, malware implications. And that contains that suspicious event, that malware implication, high frequency, privileged system call, general malicious activity, abnormal memory writes, and directors of compromise. Unauthorized files access, mass that are ransomware, and driver installation or kernel module rocket. It's called rootkit. Hidden process creation manipulation. It means stealth malware, as we can see also in the second schedule, from low to high. It's like waves going from up to down. Leveraging machines learning for enhanced detection, model accuracy, and malware detection, as we can see the percentage in the schedule lines in the analysis. Neural network has 90%, random forest has 80%, SVM has 60%, clustering has 41%. And the neural network from behavioral analyze has like 3 stereotypes, so it matches between the others. It's like the input layers, kernel behaviors, and the hidden layers, pattern analyze, output layers, and malicious bingo. We have like the supervised learning and unsupervised learning and deep learning and key insights. So we're gonna start with supervised learning. Models like random forest and the CVM are trained on labeled dataset of known malicious and Bingen behaviors to classify new unsigned data accurately. Unsupervised learning is like clustering algorithms are used for anomaly detection that identify deviation from normal behavior to patterns and flagging potential unknown or 0 days free threat without prior malware. Deep learning neural networking and offer deep learning capabilities to uncover subtle and tracked pattern and vast dataset that other models might miss. Key insights, a hybrid approach combining both a supervised and unsupervised method provides a comprehensive and robust defense against a wide spectrum of cyber threats. So we're going to go to the next slides. And it is illustrative workflow of kernel behavior analyze and action, step-by-step real-time malware detection. Malware, it has like 1, 2, 3, 4 to 6 steps. First, we're gonna start with malware execution, event capture, login processing, feature extend, pattern analyze, behavior pattern like system calls frequency are qualified. And number 4, ML model comprehension. A trained model compress extracted pattern against a known malicious profile. Alert generation, if a match or a definition is found in the system will give an alert. Real-time response, the system blocks the malicious actions or contains the process. Advantage of kernel behavior analyze. We have like the key benefit of kernel level monitoring. It has like 1 to 5 steps also with their analyze. Aviation resistance, 0 days dedication, real-time protection, and deep visibility and robust defense. Malware struggle to hide from kernel level monitoring, and 0 days has identified both unknown and unknown 0-day threats. Real-time has stopped attacks before significant damage occurs. Deep visibility reveals the true intent behind every system process. And robust defense manipulate effectiveness against advance of techniques offering a powerful protective cybersecurity strategy, as we can see in the analyze. And the last one of my slide, I'm gonna say we're gonna start with the key challenge in implementing kernel behavior analyze. Core implementer hurdles. It has like almost 7 steps. It has like a high volume of kernel events create data process challenge. Kernel level monitoring can incur performance overhead. And the third one, effective features selections is circle to reduce noises. Risks of false positive destructive algorithm operation requires deep kernel levels expectation of implementation. And the last one, like balancing performance and dedication accuracy, is a satirical. As we can see in the mitigation strategies, common challenge, potential mitigation strategy, high event volume, filtering at the source, aggregation, and even sampling. Performance overhead, use effective data structure, e.g. ring prefers offload processing, noise falls, positive advanced feature selection, baseline behavior modeling, and contain aware analysis. As we can see, we have the percentage from 0 to 15 percentage. It's like with the green one is like without monitoring. The red one is with kernel monitoring. That was my slices. Thank you for listening.
Hello, my name is Nadeem Ahmed. So today I'm gonna present my slides with my team. So I'm gonna present the real world implementations and applications. EDR architecture with kernel integration. It's gonna be connect between them like endpoint advise to kernel level and EDR agent to cloud security platform. K implementations, it's a 5. So it's gonna be Microsoft Defender ITB and Linux system and Google sandboxing and EDR solution. So the case study, dedication Rosonomy to Kernel. It's gonna be like 4 steps, like until compromise and privilege escalation and defense evasion and binary button. Like we see the picture here, it's explain how to work. The future dedication and kernel analyze, it's gonna be like a future cyber security system. There's in here in picture AI and ML integration and cross platform and real-time scoring and hardware assessing. And there's here the key trends summary, AI interrogation and real time. It's the same and the better I see it before. So the conclusions, the future of malware education, it's for like safety, for privacy, for there's so many benefits for that, like a core advantage and available check all active must pass through the kernel and deep visual process the computer and the context on system and privacy broken protection device like 0 day throw before sun access. So we can look here for the picture, like the model of how to work and how to it's gonna be work. It's gonna be connected with us or with the data space with everything. So I finished the slides and thank you so much for everything.